So question number 25, how are 0.5 molar solution of Na2CO3 excuse me, and 0.5 molar of Na2CO3 different from each other? So first of all, the molar mass of Na2CO3 will be basically the atomic masses added to each other. So 2 into 23 mass of sodium plus 12 because you have one atom of carbon, and 16 into 3 because you have 3 atoms of, or rather I'll put as 3 into 16. Yeah, so I'll put as 3 into 16 because you have 3 atoms of oxygen, and this comes up to 106 grams per mole. Now 0.5 mass of 0.5 moles of Na2CO3 will be equal to 106 grams per mole into 0.5 moles, because number of moles equals to mass by molar mass. So we're just multiplying mass into the molar mass to calculate the mass, and mole, this gets cancelled. This gives us 53 grams. So we need to find out how is 0.5 m different from 0.5 capital M, molar and molar. So the first one, that is 0.5. Oh, I'm so sorry, the question has 0.50. The reason this is important is the significant figures. So 0.50 molar solution of Na2CO3 will have 53 grams of Na2CO3 in 1000 grams of the solvent, and 0.50 capital M molar Na2CO3 will have 53 grams of Na2CO3 in 1 liter of the solution. This is basically the definitions of molarity and molality. So in molality, it is to do with the the mass of the solvent. So 53 grams of Na2CO3 is in 1000 grams of the solvent, whereas 0.50 molar is 53 grams of Na2CO3 is in 1 liter of the solution. So here is the solution, here it's just the solvent. Question number 26. If 10 volumes of dihydrogen gas reacts with 5 volumes of dioxygen gas, how many volumes of water would be produced? To answer this question, we first need to get the stoichiometric equation of the reaction between dihydrogen and dioxygen. So H2 plus O2 gives rise to H2O. But is this equation balanced? No. So to balance this equation, I'm just going to write 2H2 plus O2 gives rise to 2H2O. You can solve this step by step, but this is by the various steps that we discussed. So this is the balanced chemical equation. So according to this, 2 volumes of hydrogen reacts with 1 volume of oxygen to form 2 volumes of water. Right. So if 10 volumes of hydrogen is present, and this is dihydrogen is present, and this is reacting with 5 volumes of water, how much would be the how many volumes of reacts with 5 volumes of oxygen, how many volumes of water would be produced? Simple. So if 2 volumes is giving 2 volumes is reacting with 1 volume. So here the ratio is similar. So 5 ones are 5 twos are. So the ratio is right. And then according to this, if 2 volumes reacts with 1 volume, we get 2 volumes of water. So 10 volumes will react with 5 volumes to give us 10 volume of water. So we're just, so in this question, we just took the stoichiometric equation and then we solved it. Question number 27. Convert the following into basic units. So we have been given three numbers along with its units. So they're basically not the SI unit of those values. So for example, picometer, the SI unit for length is meters, and for microsecond the SI unit for time is seconds, and in case of milligrams the SI unit of mass is kilograms and not milligrams. So we need to convert them into the basic units, that is the 7 basic SI units. Okay, so this we'll be doing by the unit conversion method. A 28.7 picometer has to be converted to meter. So 1 picometer equals to 10 to the power minus 12 meters. So our unit conversion factor is 10 to the power minus 12 because we need the answer in meter, divided by 1 picometer. So 28.7 picometer equal to 28.7 picometer into 10 to the power minus 12 meters divided by 1 picometer. This and this will get cancelled. So 28.7 into 10 to the power minus 12 meters. This can also be written as 2.87 into 10 to the power minus 11 meters, because we are shifting the decimal to the left side. So, and in our scientific notation, we need to have only one number before the decimal point. Next one, 15.15 microsecond, and this has to be converted to second, which is the SI unit of time. So, 1 microsecond equals to 10 to the power minus 6 seconds. So our unit conversion factor is 10 to the power minus 6 seconds divided by 1 microsecond. So 15.15 microsecond will be equal to 15.15 microsecond into 10 to the power minus 6 seconds divided by 1 microsecond, and this is equal to this, and this gets cancelled. So 15.15 into 10 to the power minus 6 seconds. This can also be written as 1.515 into 10 to the power minus 5 seconds. The third one, I'll just write it here, 25365 milligrams to kilograms. So we know that 1 milligram, or rather 1000 milligrams equals to 1 gram. Okay, and 1000 gram equals to 1 kilogram. So our unit conversion factors, so 25365 milligram equals to 25365 milligram into, first of all you have the milligram on the numerator, so we need the milligram for this unit conversion factor on the denominator. So 1 gram divided by 1000 milligram into, here you have the gram unit on the numerator, so you need it on the denominator. So 1 kilogram divided by 1000 grams. So gram, gram, milligram, milligram cancel, and this leaves behind kilogram. So you get the answer as 2.5365 into 10 to the power minus 2 kilograms. So we just use the unit conversion method, and since we are talking about basic units, that is nothing but the 7 basic SI units. For length it's meters, for time it's second, and for mass it is kilogram.